The scientific method. Formulation of an hypothesis. Definition of the problem. Statement of objectives. Planning an experiment to objectively test the hypothesis. Selection of treatments. Selection of experimental material. Selection of experimental design. Selection of the unit for observation and the number of replications. Control of the effects of the adjacent units on each other. Consideration of data to be collected. Outlining statistical analysis and summarization of results. Careful observation and collection of data from the experiment. Conducting the experiment. Interpretation of the experimental results. Analyzing data and interpreting results. Preparation of a complete, readable, and correct report. The well-planned experiment. Simplicity. Don't attempt to do too much. Write out the objectives, listed in order of priority. Degree of precision. Appropriate design. Sufficient replication. Absence of systematic error. Range of validity of conclusions. Well-defined reference population. Repeat the experiment in time and space. A factorial set of treatments also increases the range. Calculation of degree of uncertainty. Planning experiments. Experiments are conducted to obtain new facts or to confirm or deny results of previous experiments. There are 3 types of experiments. 1. Preliminary. Investigator evaluates a large number of treatments in order to obtain leads for future work. 2. Critical. Investigator compares responses to different treatments using sufficient observations of the responses to obtain reasonable assurance of detecting significant differences. 3. Demonstration, performed by extension agents, experiment stations, or seed or chemical companies to compare new treatments with a standard. Planning the experiment. 1. Write down objectives in order of importance. This will help you choose the correct experimental design. 2. Write down the hypothesis to be tested. 3. Define the population you plan to sample. 4. Select the specific treatments for the population. Example. Determine the response of different wheat cultivars to foliar-applied fungicides that control wheat stem rust. 1. Objectives. To determine the effects of foliar-applied fungicides that control rust on agronomic traits of wheat. A. Yield. B. Disease score. C. Spike length. D. Grain weight. E. Test weight. F. Grain protein. G. Number of grains per spike. H. Plant height. I. Days to maturity. J. Lodging, etc. 2. Hypothesis. An application of foliar fungicides to wheat has no effect on agronomic characteristics of wheat. 3. Population to sample. Wheat cultivars grown in central Punjab. 4. Fungicides labeled for use on wheat. 5. Specific treatments, cultivars and fungicides be used. Before treatments are considered, many items need to be considered. A. Where to conduct the experiments. B. How many and which cultivars to use. C. How many and which fungicides to use. D. Size of plots. E. Seeding rate. F. Spraying rate. G. Method of spraying. H. Amount of pressure to use for spraying. I. Amount of water to use to carry fungicide. J. What surfactant, if any, to use. K. Stage of growth in which fungicide is to be applied. L. Will plants be inoculated? M. What notes to take? N. How much time will the experiment take? O. Amount of labor needed to conduct the experiment. P. Amount of money needed to conduct the experiment. Experimental unit, unit of material to which one application of a treatment is applied. Treatment, the procedure whose effect is to be measured. Experimental error. 1. Measure of variation that exists among observations on experimental units treated like. 2. Failure of observations on experimental units treated alike to be the same. 2 sources of variation causing experimental error are: 1. Inherent variability that exists in experimental material treated alike, variability in the field, different starting weight of animals, etc. 2. Variation that results from lack in uniformity in the physical conduct of the experiment, e.g. poor experimental technique, poor emergence in the field, etc.